Hi, this is Mrs. Baden. In this video, we will be talking about the laws of exponents. We will be using the Freyer model to organize our notes instead of the Cornell notes that we've been using in the past. So make sure that you have your sheet that has this model already set up and ready to go. The first rule that we will be looking at is the product rule. So when you are using the product rule, you are going to want to make sure that you have the same base. We are going to multiply them together, and so this is what an example would look like. X cubed times x to the fourth. Now when we expand that, this is what it's going to look like. X to the third times x to the fourth. X to the third is x times x times x. X to the fourth is x times x times x times x. And when we combine all of those together, it's the same thing as saying x to the seventh. Now, as a reminder, when you are using the product rule, you're going to want to make sure that you keep the bases the same, but just simply add the exponents. This is the shortcut that you will be using with the product rule. So let's look at some examples. The first one is being 5x squared times x to the fifth, and that just simplifies to 5x to the seventh. Another example is 2m to the fourth times 3m. Now what you would do is take 2 times 3 to get the 6, but then you would add the exponents with that m to the fourth and that single m, making it m to the fifth. We can do this with values and not just variables. So 3 squared times 3 to the fourth is the same thing as saying 3 to the sixth, and that equals 729. Make sure to pause this video that way you have all of these notes written down in your organized note sheet. The next example we will be doing is the quotient rule. Now with the quotient rule, you'll have the same base, but they'll be using a division symbol or a fraction sign, such as the examples written below. Q squared using the division symbol divided by Q, or can be written as a fraction, y third divided by y squared. When we expand this out, we can take a look at these two, this example here. P to the eighth divided by P to the third. Well, p to the eighth is p times itself 8 times, and p to the third is p times itself 3 times. We can see that we can make giant ones to simplify this expression, and what we're left with is just p to the fifth. So when using the quotient rule, we need to remind ourselves to keep the bases the same, and then we will be subtracting the exponents. So depending upon the style of the problem, you're either going to do the top minus the bottom or the left minus the right. Let's take a look at some examples. M to the sixth divided by m, we'll just subtract those exponents, giving us m to the fifth. X to the third divided by x to the sixth, when you subtract those exponents, you get x to the negative third. Again, we can use these with values other than variables, so 7 to the fifth divided by 7 squared equals 7 to the third, or 343. And then if we look at the left example, this one's more complicated because not only do we have values, but we also have variables. So we'll just do simply 4 divided by 2 to give us the 2, and then y cubed divided by y will subtract those exponents, giving us the y squared. Again, make sure you pause this video to copy down all of the notes onto your Freyer model note sheet. The last rule that we'll be looking at is the power rule. And when we're looking at the power rule, the parentheses contain a variable with an exponent, and then on the outside of the parentheses there will be an additional exponent, as you can see with this example here. R to the third to the fourth power. How do we go about simplifying this? When you take a look at x squared to the fourth power, it's the same thing as saying x to the squared times x squared times x squared times x squared. But when you expand all of those x squareds out, you end up with 8x's, or x to the 8th power. When you have an exponent problem like this, you're going to want to make sure to distribute this exponent to every base in the parentheses. What this simplifies to is multiplying the exponents. Let's take a look at some examples. If we have x to the third to the 5th power, we'll multiply that 3 times 5 to get x to the 15th. Y to the negative 2 to the 3rd power, when you multiply those, you get y to the negative 6th. Now let's take a look at this more complicated example that not only has the product rule, the power rule, but also a quotient. So we'll distribute that 4 to not only the 2, but also to the x squared and to the y to the 4th, both in the numerator and in the denominator. So you can see off to the right that I wrote 2 to the 4th. I multiplied x squared, so that 2 times 4 to get x to the 8th. And then I also did it to the denominator. For that y to the 4th, I multiplied the 4 times the 4 to get y to the 16th. My last that you see in the bottom right is me just evaluating that 2 to the 4th to give me 16. Again, go ahead and pause this video to make sure that you have all of these copied down into your Frayer model notes. Let's work on some examples together. This first example reads 5 times h to the 2nd equals times 2h to the 24th. We are simply going to multiply the 5 times the 2 to get 10, and then h squared times h to the 24th. Well, that's our product rule. So all we have to do is add those exponents to give us h to the 26th. Let's take a look at another example. 15p to the 4th, q to the 5th, divided by 3p squared, q. Simply divide the 15 divided by 3 to give us the 5. Using the quotient rule, subtract those exponents, making sure they have the same bases. So I'm going to do the p's first. So p to the 4th divided by p squared. Subtracting those exponents, I'm going to get p squared. Q to the 5th divided by q. Subtracting those exponents, I'm going to get q to the 4th. Let's take a look at another example. 3k to the 20th power to the 4th power. So we're going to evaluate it as if it was 3 to the 4th and then k to the 20th times 4. What that simplifies to is 3 to the 4th is 81, and then since we are multiplying those exponents, we're going to have k to the 80th power. With this next example, again we have both the quotient rule and a power rule. So we're going to go ahead and simplify the inside of those parentheses by using our quotient rule and subtracting those exponents. So what you will see is that I end up with, we're going to erase those previous answers, is I'm going to end up with m to the negative 7th, still to the 4th power. Now when you simplify that using the power rule, you're going to multiply those two exponents. So in the end, I'm going to end up with m to the negative 28th power. Let's take a look at our final example. We are going to want to first simplify the left side, then simplify the right side, and then combine them together. So the left one first is going to be 2 to the 3rd, m to the 3rd, and then we're going to multiply that n to the 15 times n to the 3rd, so that's going to be n to the 45th power, times, again, we're going to take a look at the right, distributing that exponent using multiplication, m squared n to the 8th. And now, using the product rule, we're going to combine our m's and our n's together. So 2 to the 3rd is 8. M to the 3rd and m squared, when you add those together, you're going to get m to the 5th. And then we have n to the 45th plus n to the 8th. So that's going to be n to the 53rd power. Go over these examples if you need to. Rewatch the video to make sure you have all of the notes correctly. But then move on to your practice problems.